Welcome everyone to my channel Space Remote Sensing and GIS, and today we are going to discuss a very interesting topic over earthquake deformation mapping using the DinSAR technique. Okay, so over the Sentinel-1 datasets. So if you see, this is a very complicated process actually, so but still we will try to give you the process and idea about how we are going to do this particular work. Okay, in this tutorial we are actually going to show you this process over the SNAP software, which is a version 8. It's a little old version, so there is a different version wise it was actually improved, but whatever I have experienced before that was over the SNAP 8, so I will going to show you over that. But in future maybe I will come with your advanced versions of the SNAP, as well as in NV also we have create a deformations map that also I will going to discuss, and with the SARscape technique, and as well as also we will going to discuss about the SARscape analytics techniques. So we will give you a detailed idea about this. Okay, so this will be a little lengthy and technical video, but I will suggest, but whoever will be interested, because very few people are actually working on this. Okay, but it is very useful technique. So I just first show you the process of the methodology, how we are actually going to use this approach. Okay, so then we will going to show you the process. Okay, so this is the earthquake deformation model which I just created. Okay, so which I just applied over here. So basics things, first you have to start, like you have to take the before and after SAR paired image which you have to take, and you have to see this image is suitable for the interferometric process or not. Okay, so once you done that, then you have to do the InSAR stack overview. Okay, so this SAR stack overview is basically giving you that idea which I am talking about, like this pair will be suitable for your analysis or not, that you can check first. Then the first steps which we will going to do, that is the Sentinel-1 TOPS code registration process, which we will going to co-register the different informations of this image. Okay, so one after another. Okay, and then basically we will try to create the interferometric formations. So interferogram, whatever you will see, so that basically we will going to create in this particular process interferogram generations. And then there is a correction techniques which is basically called Sentinel-1 TOPS debursting, so that we will do, and then we will focus over the topographic phase removal process. And to make the data more clear and noise removal, we will use a filtering technique usually over the SAR images. So in this case a technique which is called Goldstein phase filtering techniques, that we will going to apply. And then we need to calculate the SNAPHU which you export for SNAPHU for the phase unwrapping. So it is basically, you call it as a phase unwrapping technique. It in NV it is very easy actually, this process all. Okay, so one by one steps it will go done in a one workflow. Here also we little bit because I am using the little old version, so we need to do little bit of changes on this. Okay, like we need to install a SNAPHU file, setup file we need to first download. Okay, it's not install actually, you have to extract the file. So inside that you will get a 2 file, and once you calculate the SNAPHU phase unwrapping file, so that is this process, whatever the files which will be generated. Okay, so that file you have to copy, and you go in a command file. Okay, and using this unwrapping file file name, and if you click enter, so then it is start importing all those files inside that SNAPHU folder. Okay, then set up as a the SNAPHU setup which you need to import. Once we import that, then we will calculate the phase 2 displacement map, and then finally we will use the range Doppler terrain correction techniques to get the exact geometric corrected displacement map. Okay, so that is a little complicated technique, so let's start with one by one. And as I told you, like this technique is a very huge process, and it will take me almost 4-5 hours to finish this full process. So what I will do, like I already calculated all these outputs, which I will show you one by one steps. I will clearly explain you, and I will going to show you one by one process. Okay, so let's start with the very first thing over the SNAP. So let's go to the SNAP and show the first step. So I just tell you about the process of downloading the this particular data sets, the earthquake. Suppose if you want to download, okay, so how we're going to download this? This is just I explained already, just for you remember, because it is a SLC product which you have to download. Okay, so that you should be very careful. Just type Sentinel browser and come to the browser, and then I will show you how the process of downloading. So first you just log in with your ID and password. So what you have, so simply log in with that. Okay, I'm just logging with this. Now just wait to it will come. So the area which you have to download, so that you have to usually we zoom in, but in this case I already have that data. Okay, so there is another process of directly you can search that data set. So I'm in this video you can check this data range. Okay, so you can note down, and if you want to use this data set, so then you can use these data sets also. Okay, directly you can download for your practice, you can use this data. Okay, so what you have to do, how to download this data. So suppose if you go in a search option, okay, in a product name, if you just simply paste it, okay, and nothing you need to do, but simply click on search. Okay, so the available data, it will going to show you in the list in a few seconds. So you see this now, it is actually showing the location. So if you click over this, so it is exactly show you the data particular data sets. Okay, and if you want to download this data set, simply click that. So this is a if you see this is the after earthquake incident data sets, and there is another data deformation map, so which is the before map. So this is the before map. Okay, the similarly you just copy this and take the before. So because see here one thing is very important, like that is the path of these two data sets should be same. Okay, so that's why it is very important. And here in this case just for demonstration, so maybe my data gaps of the days are little more, but it should be always focus, it will be nearby date, so then it will be easier for you. But sometime you may not get the same scene of same locations. Okay, so you have to take some different date. Okay, so this is what, now if you just simply click on this, so data will be downloaded. So I already downloaded this data, if you've seen. Okay, so this is my before data, and this is my after data sets. Okay, the two data sets are ready. Now let's go to the SNAP. Okay, and see the first what I did, I add the two data sets. Simply if you go and open a box, okay, so I will show you the before and after data. So this is my before data, I just select it and click on open. Similar way you have to click on the after data sets, okay, and select and open. So this is the two thing you have to do, the first to add this data. So I will show you this data if you want to see. So suppose this is how the SLC products is actually coming with the different bands. Okay, so this is what you have to see. So this is a very huge data sets, like SLC products are really very heavy. Okay, it will take quite amount of time to open these data sets. Okay, so there is an important thing, the size of these data sets are also huge, means it's near to 8 GB. If you start working, it will go to more than 16-17 GB, and if you finish the process, my already this drive is cross 100 GB. So before starting this kind of interferometric process, you should be very careful about the space which is required. Okay, now the next step. So very first, if you see in the navigations, it will show your map. But in the world locations, if you want to see this, so this is, you see the red location which is showing, so that is actually your location. Okay, so this is the locations of that particular image which we are actually considering for our analysis. Okay, so now let's start the next process, how we'll do, that is called stacking. Okay, because in this case what we have to do, these two different types of dates now, we need to do stacking first. Okay, so but this is an interferometric stacking, so that we will going to do first. So this scene will be suitable for this analysis or not. So before stacking, so you should check that the overview also. Okay, so the overview you will going to check from here, like radar. If you go, Okay, then go to the interferometric, and this is called InSAR stack overview. Okay, so this is what is very important here. So usually it should be this two image we need to add. Okay, so this is the two image. If you click here, add open, so here actually it is came all the bands. Okay, so usually we need to add this first two bands only. Okay, so as I mentioned, like it is actually all the bands which I already processed, so that's why it is coming here. But when you are first time you are doing, this two bands is required, before and after image. Okay, and now you have to see the overview from this. So if you click on the overview, the statistics will calculate it over here. Okay, so these are the all the statistics which is help you to understand about the data which will be useful for it or not. Okay, so that you have to see. So you will see, you can get the all the informations about the two image, the acquisition date. Okay, you just need to see the orbits. Okay, and the track. So track should be the same. That is a very important, as I told you. Okay, so the both track should be the same, then only it will cover the same area. Okay, so then the coherence. Okay, so coherence is also an important factor, so that is you need to check. Okay, so this is the height of ambiguity and its delta value. So all these parameters which will give you the certain idea about the this image is suitable for your interferometric studies or not. Okay, so now we have to do some pre-processing steps to start our interferometric journey. Okay, so that I will going to explain you now. So the first steps which we need to do, that is the code registration process. Okay, so if you come to the radar, okay, so here we have the code registrations. Okay, so here we need to do this one. Okay, S1 tops code registrations. Okay, and you need to click on the Sentinel-1 tops code registration process. Okay, so that is we need to first steps we need to do on this. So the first things which we have to do, that is the read one. This is your first image. Okay, so and this is the second image. Okay, so this is the two different image you have to select. Okay, so if it is the first one and then second one, you need to go and drop down to the second image which you need to select. Okay, so this is the two process which you have to do properly. Okay, so this is 49 and this is B32 49. Okay, so this is how we need to select the so this is 49. Yes. Okay, so this is for 93. Okay, so this is the first one 93 and second one is your 49. Okay, so that is how you have to select these two image first. So if you see here, like the next one I select the 93. So first one is your the 93 one, so second one is your 49. So before and after these two image. So now you come to this split SAR. Okay, so if you usually see here, we have three mode, like IW1, IW2 and IW3. So here you have to concentrate like which area and locations your study area is actually fall. Okay, suppose for my this case I'm going to select this is the particular locations which is falling. Okay, and then bastings whatever you want, so accordingly you select the basting. Okay, now this is same thing you need to do for the top surface for the scene 1, then simply we need to do for the top surface split 2. Okay, this two process you need to do the same for the both. So the next important step is the apply the orbit file corrections which you need to apply it. So this is a Sentinel precise, it is by default selecting. That means if you use this, okay, so it will precisely download the orbit file, so your accuracy will be more higher. Okay, so but if you don't have this file, so then also this will be download, so this do not fail okay, to if the new orbit file is not found. So that is what you have to get, because this orbit file it will create after 2 or 3 days of the passing. Okay, so that's why suppose if you want to do some immediate study of the earthquake, so maybe that orbit file is not created, so that's why you need to always check on this file, and then finally you can go to the back geocoding process. So the next important step is, if you see the back geocoding process, so if you come to the process, so there is a different kind of TM is there. So usually we use the SRTM 3 seconds image. So that is what you are going to use for this. Okay, you select that. Okay, and then finally you have to save the process where you are going to save your data. Okay, so the thing is how we're going to identifying this is the stack image. Stack image is both images stack in a one place. Okay, so this is basically which is called as a stack image. You can very easily understand. So last process means when you click on this last process, you will see it will be written as a stack. Okay, so if you click on the run, so this process will going to start. Okay, so I will going to show you directly the output how it is actually created. Okay, so for this, if you see this, so this is my first stack image. Okay, so this is the first stack image which will come together is like this. Okay, so if you want to see this image, so just intensity image you open. So this is the first steps which is the stack image is actually created over here. Okay, so the next steps what we need to do, that is interferogram generations. Okay, interferometric generation. So the same process we need to go to the radar interferometric. Okay, so you see the products and you have to click on the interferogram generations. That is what you need to go, and the output, the last output which you just created, so that is need to select. Okay, so that is you need to be very careful about the selection process what you are actually selecting. So if you don't be able to see, so this is the process. If you, okay, so like if you see this is the stack image, so whatever the stack image you generated, you need to select that. Okay, and then come to the processing parameter and you need to select. So now here in this is the processing parameter, I will not change anything here. Okay, so now wherever you want to save your data target, okay, so that you just give the location where to save. Okay, so that is important. And now you see the next process which we just running, that is the interferogram. So the the output in the end it will be written like this IFG. So if you click the run, so now your output is going to ready. So I already created the output, so I will going to show you how it is, because every process it may take 10 to 15 minutes time to process this data. It's a huge data actually. Okay, so to showing you that, I will just close this. Now this is the next output which is created. So this is the band IW3. Okay, so now I'm going to open the. So in this important is the phase value. Okay, so if you see this is the phase, interferometric phase, so that is how it is opening. So this is the phases which is coming over here. Okay, so most of the area is actually hilly, so there is a noises also there. Okay, now we will need to do the correction so that you may get a good informations of the image. Okay, the next steps which we are going to do, that is the called Sentinel-1 tops debursting process. Okay, so the debursting process I will going to show you how we are going to run this particular process. Okay, so that process you need to run from here. If you need to go to the radar, okay, Sentinel-1 tops, and this is called Sentinel-1 tops deburst. So if you select it, now which one you need to give input here, this one IFG image. So if you come down, okay, and or you can go like this. So see, it is already selected that process. Okay, so always remember whatever the process you are actually running, so last the things which you need to see, which is that. Okay, and then accordingly you need to process this. Okay, now go to the processing parameter. Over the VV polarizations I'm going to run this process. So if I click on the run, okay, so now you see I already created this process, and I will going to show you now how that will be. So here if you see here, once you finish this process, okay, so this is the data which will be generated, which is actually generated. So now if you see, this is my this is the debursting interferogram debursting image. So if you right click and open, so this is the image which will get it here. Okay, so this is some phase changes which we found over here, so that's why I'm just showing you on this particular location. Okay, so now the next steps which we need to do, that is I will going to show you now. Okay, that is the DinSAR techniques which we're going to apply. So let's see. So the next steps which we're going to run here, so that is topographic phase removal. So for this you need to go to the radar interferometric. If you go to the products, okay, and this is called topographic phase removal. Okay, so now here also you just need to give your deburst image, okay, as an input. Okay, so this is the deburst image which you need to create and build. So this is basically DinSAR. which we are going to create it here. Okay, so now once you go and select on this, so it is required a SRTM DEM which we can download by automated technique. Okay, so simply you select that product output, okay, and then simply click on run to generate this output. So now I'm going to show you this output, how it is generated. So now you see this is the DinSAR product which we generated. So if I click on this, go to the bands, and you see if you need to see the phase output, so I will close this one. Okay, so now let's open this one. Okay, phase output, and see this is the how the phase output is actually generated. Okay, so this is the DinSAR phase output is generated perfectly now, which we are going to apply. So that is basically the filtering process which we will going to apply the image. Okay, so in this before I will go to the next step, so I will show you this another important things which will created over here, that is your coherence outputs also. So I didn't show you this before. So this coherence is very important for the certain changes. If you do some analysis over the certain changes, usually we applied many things for the coherence. I used before one work over the certain changes in a earthquake or certain changes in due to the bomb blast. We can identifying the in the cities if something has happened, uncertain change within before and after, right? So that we can identify with this coherence value also. Okay, so anyway, now we move to the next step. So the next steps which we are going to perform, that is filtering. As I told you, now we can go to the radar. We need to go to the interferometric and the filtering. Okay, so here we have different types of filtering. So here in this case we are going to use the Goldstein phase filtering. Okay, so this is what we are going to use it now. So in this process also you always remember the last steps which you are actually run, that is the InSAR. Okay, so that you need to give as a input here. Okay, and you see here the output which will be generated, that last will be showing as a filtering. Okay, now here if you go to the processing parameter, okay, so it is fine. Okay, so you not to change anything here, so simply click on run. So this is what it will do, that is it is reducing the noise from your image. Okay, so that is what we are going to do it now. So I'm just now going to show you the output so that you can understand how it is after filtering. So now if you go here, okay, so in the filtering, so if I go to the bands, okay, so this is your face image. Okay, after filter, okay, so you see how smoothness which will became over your image. Okay, similarly if you see the coherence image, this is a filter image now. Okay, so that is how it is coming. Okay, so that is what we have to check always. Okay, so this is a before if you see, and this is the after filter. Okay, so see how the differences between the these two. Okay, so that you can understand the changes. Okay, so after filter, how the smoothing will be applied over image and your noise will be reduced a lot. Okay, so the next steps, which is the very important steps, which is called unwrapping steps, which we will going to start now. So now to doing these steps, as I told you, this is the phase unwrapping step. This is a very crucial steps. Okay, so now if you come to this radar, okay, so go to the interferometry. Okay, this is unwrapping. So first things which you have to do, that is the export. Okay, SNAPHU export. Okay, so this is the things which you need to run over here. Okay, so now we need to run this process. So one thing you need to do it here, that is if you see here, this is basically you need to run the last image which you are actually did it over here. Okay, so I just show you. So this is the last image which we did. Okay, so you need to select it there. Okay, so which is already selected. Okay, filter image. Okay, now here in this is a very important thing which you have to do, that is you have to create a target folder. So if you click on this, so I will show you, I already created this folder. So this is the folder which I just created. If you see here, I just click on this folder option, okay, and create a new folder. I can give this name as a SNPHU, that is the folder which I created. Okay, and then select it and then open and give the name and run this. So now you see here in this SNPHU folder, I just give another name. Okay, so that is also name I given as a SNPHU, and then select and open. Okay, so and this I just run. Okay, so if you click the run, okay, so now your unwrapping image will be ready. So now this is a very crucial steps which you will going to start the next. So once you run this so you need to go to the folder where you are actually creating this data, so that you can understand like how this is actually generated. Okay, so once you run this, so this is the 6 file it will going to generate 1 2 3 4 5 6. Okay, so this is the 6 file which is generated under the SNPHU folder. So now what is, if you see here with the coherence and the phase file we have the img file, but for the SNFU we don't have this as an image file. So that is what we need to be generated. So before that, you just, if you open it in a notepad, okay, so if you see, this is the value which you have to create it as an image. Okay, so that is what we need to do it now. So for converting this, you required a SNAPHU setup file, because I am using the SNP8. So for this case, you need to require to do this process. Okay, so you need to go to the Google, okay, and you need to download the SNAPHU download. Okay, so if you just search like this, so this is the SNAPHU setup file which you will get it from this link. So just right click and open it as a new tab. So under this you see manual installation process which is given you here. So if you just using according to your bit of your data, like my one is a 64 bit, so I just simply download this. Okay, and I just kept this to over there, means where I just downloaded. After downloaded, I will show you like you will save this here, like this is the exe file. So if you just right click and extract, okay, so you will get the file over here. Okay, now in this basically the two values are there. Okay, because what we need to do, like whatever the values we have here in SNPHU, so that 6 value we need to copy it from here. Okay, and we need to paste it here, which I already did. If you see here, if you go in a bin file, and here mostly you need to paste this file. So if you may not understand from here which is the file actually, but I will show you so the separately to extract, so that you can understand. See, if you copy this now, I will paste it outside so that you can understand. So if I paste it, if I just extract all, okay, so under this, if you see, only bin 2 files are there. Okay, there is no other file. What I did actually, that is, you need to go to this output SNAPHU. So you need to copy this, all these 6 files, and like this, if you copy it, okay, and come to this file which I already have here, bin, just paste it. Okay, so this is what you need to do. Okay, so this is a very important step here. So now the folder, you see, it should have the 6 files, or total 8 files. Okay, 1 2 3 4 5 6 7 8 files. Now from within this folder you need to select like this and click on CMD and click on enter. Okay, so this is what it will come. Okay, and now here you need to copy that snap file and paste it here. I will show you this process. So come to this folder, if you just right click and open with this with the notepad, and this is the file format which you need to copy and paste it. Now here there is a very important step, as I told you, like you need to select this file. Okay, just copy it, come to your command file, and here you just need to see in the bin folder. Okay, what's the same bin folder, okay, that you need to paste it, V. And if you click enter, I am not doing the enter, because if I start enter, it is start creating file, and it is taking a lot of time, because it was taking almost 1.5 hour time to finish this particular process. But when one thing I just mentioned you here, if you are not using the software version 8, okay, so then you will face this issue. But if you are using the software version 8, so then I don't think you will face this issue again. Okay, so means as I faced this problem, so that's why I just mention it to you. But when I degraded it to in the version 8, so I didn't face this problem. Okay, so that's what, if I click on the run, so the process will run. So I will not going to run this process, because I already created this data, so which I'm going to show you now. Now after running this process, what it will create it, I will going to show you. This is the file output which you already created that time. This is this one. If you come to this bin folder and see, this is the unfaced IMG image. Okay, so which was missing earlier. Now this IMG image is very nicely created. Okay, which is our main input which we need to use for the face unwrapping data, which we are going to use for the next step. Now let's go back to the snap, and if you see here we have the SAR. Okay, so interferometric unwrapping. So now here what you need to do, that is you are actually importing the files. Okay, so now we are going, yes, so here I will going to import the file. So see, in the first reading the first phase, you need to give your filter image, DinSAR filter image, but in the read 2 you need to give that unwrapped phase image file which you just created under this bin. So this is your file which you just created, and simply select and open it over here. Okay, so now you need to select this as your file, okay, which you created. Now come to the snap. This is no need to change, so come to here. So wrap file, you see where you want to save this. So that location you will see all the data file which will be here, that should be here. And here one thing you need to add, that is the next steps which you are actually did, that is unwrap. So it is not coming by default, so you need to write it here. Okay, so you just need to select like this and then simply click on run. So once you run, your unwrap file will going to generate. So this is your unwrap file which is created. Okay, so if I come to here, go to the band, this is the unwrap face. Okay, so if you double click, it will open. So this is the unwrap face image, how it is looking like. Okay, so now we are going to create the displacement map. So for this particular steps, we need to go to again from the radar, interferometric. Okay, so we need to calculate the phase to displacement. So this is basically, this is basically from interferometry product. Okay, and this is that, okay, phase to displacement. So if you want to create the high resolution digitalization model, then go to phase to height, and in this case I'm going to use the phase to displacement map. Okay, so this is the very crucial steps where we need to give our unwrapped image as an input here. Okay, and you see this is the processing parameters which is not required. So here you just see the last process steps will come as a DSP. So simply click on run, and we will see how the displacement band image is actually created. So these steps is basically showing you the before and after. So after the earthquake, what the vertical displacements will be happen. So what is the area is going high, where is low, how much is happen. So that will be calculated as output. So let's see how this output is actually created. So now I'm going to show you phase to displacement, how the image is created. So if you come here, go to the band, this is the displacement. So this is how the displacement image showing. So more this actually, it will actually show you the more displacement area. Okay, so if you go far, so that is the less. Okay, so that is how it is come, but still it is not geometrically corrected. So what we need to do means we need to do the terrain corrections over this image, so that we will get the accurate image, and we can take it to any GIS software or any software, ArcGIS Pro or any other software, to do the mapping or analysis. So which will going to show you here as a meter. Okay, so if you see, this is the scale which will be seen over here. Okay, so that is what it is showing it here as a displacement map. Now from this radar, we can go to the geometric and terrain correction, and we will going to use the range Doppler terrain corrections for this output. This output is not that much great, but at least I can explain you the full process which will be there. So I hope it will be very useful for you all. So this is the present output, which is your unwrap image, which you need to give it over here for the next process. Yeah. So this is basically the source product, which will be your displacement product. Okay, so and name of this product. Okay, so that is basically your terrain corrected product. So that is, I just make the selection of the unwrapping. So it is not unwrapping, the last steps which we did, that is the displacement map. So that we need to select, and you see the final output, which will become you as a terrain corrected image. Okay, so wherever you want to rate, so here for the terrain correction, the pre-processing parameter for digital elevation model, so according to your output you can select. And in the source band, this is the displacement which we are actually using for. Okay, so now we come back to this. Okay, wherever the location, final locations you need to save, you just check it over here. Okay, and we just need to run this. So mask this area, we can off this process. Okay, you need not to use this one, mask this out of area of the elevation, so that you need to mask off, and then select the source band. That will be fine for you. And next you just need to run this process. Like if you come here and then simply click on run. So once you click the run, I am not going to run it again, it will take time, so I will directly show you the output. So now I will going to show you, this is the final output displacement and terrain corrected map. So I will close all this and I will open it as a displacement map. Yes. Okay, so this is your final displacement map. And what are things I did, that is I've just converted in a linear to dB, and I can save it over here also. Okay, so that I can play with this histogram of this map whenever I'm taking it anyone. So in this map, if you see this area where the source of the earthquake and the displacements will be the more according to this particular scale, and if you go more from the color, you see the displacements will going down accordingly. So this is more far, so there's a less displacement. So where is this locations? Now if you want to convert it to KMZ file, so you can open it in a Google Earth, or you can open it in a ArcGIS Pro. So it is in IMG, so it is no problem, it is directly open in ArcGIS Pro. Okay, or you can open it in a Google Earth also. Now how we will going to understand this is your geometrically corrected or not? So for that you can do one process, like if you go in a file, you can go to the import options. Okay, you can either vector data, you can see the shape file option. So if you have the shape files of the locations where the earthquake is actually happened, okay, so the affected area, okay, so that you can take it and just open it, so it will be fall down over that. Okay, so this is boundary is actually not supported, otherwise it will be definitely open. Some error is coming, but anyway this data is actually ready. So if I'll show you, if I have that output in ArcGIS Pro, so that I can show you that also. So now I will show you the two process of how you will open these data sets in Google Earth or ArcGIS Pro. So this is already in a, as I told you, it's an image format, so you can directly open in ArcGIS Pro, but I will try to show you the quickly if you want to open. Okay, so you can go to the export and other format, and you can simply click on this okay, Google Earth KMZ file. You can just click it. So this total file will convert it in a KMZ, and directly it will open in a Google Earth. So this is in the Google Earth. Okay, so over this you can very easily understand your locations where the incident will happen actually here. So this is the source of the earthquake, how it is looking, and there is a more number of displacements which is actually showing, most of the vertical displacements which will showing over this particular location. And if you want to open it in ArcGIS Pro, so simply you can go to the add data browse where you have these two data sets. You can simply select and open this data, which I will show you. You see here, this is your terrain corrected data, so displacement VB, so which I converted is a linear format. Okay, so because this is very easily to control in ArcGIS Pro. So select it and then click on OK. So once you click on OK, so this is the deformation image which you will get. Okay, so this is the big process which we are actually discuss today. Okay, so I hope you like this video. This is little lengthy video and very complex to understand. Okay, so it is not an easy task to understand this process, so I will request everyone, okay, so go through the video 1 or 2 times and understand about the technical details. Okay, so because here in this image also the phase is not that much clear. Okay, but I will show you in future with some good image where the phases are very clear. Okay, so I already have a previous some lecture on NV which I already delivered, so you can go and check on the that also lecture also. Okay, and in future I will going to show you with the latest NV 6.0 how we're going to do this process. Okay, with the both SARscape and Sascape analytics. Okay, so this is very interesting and very interesting area to explore. Okay, so that's all from my side. So if you like this video, please share with others. Okay, so and if you want any kind of technical consultant advice from me, so then I will be always there to help you on that. Thank you very much.